This is Pre-Calc Chapter 2 Quiz Review. Graph and analyze the function, describe the domain, range, intercepts, and behaviors, continuity, and where the function is increasing or decreasing. So we're going to start by putting the equation into our y equals and graphing the function. The graph is going to get close to the y-axis and never touch it. Then get close on this side, and then get close to the x-axis and never actually touch it. So our domain in this case is that x cannot equal 0. Remember, you can also write this as negative infinity to 0 and 0 to infinity. To find the range, we also know that it's never going to touch at y is equal to 0. Again, we can write this as negative infinity to 0 and 0 to infinity. We need to find the x and the y intercept. The x-intercept is where it's crossing the x-axis, and it actually never crosses the x-axis anywhere, so there's none. And the y-intercept is when it crosses the y-axis, but since it never crosses the y-axis, we also have no y-intercept. We're going to look at the end behavior on the left side, and we're going to look at the end behavior on the right side. On the left side of our graph, as the x value gets smaller and smaller, the y value is getting closer and closer to 0. On the right side, as our x value gets larger and larger, the y value is getting closer and closer to 0. Now, because our graph jumps up here, goes to the infinity at the top and the infinity on the bottom, this is not a continuous function. We can't draw it all without picking up our pencil. And this is actually an infinite discontinuity. And we need to say when the graph is increasing and decreasing. So starting from a very small x, from the negative infinity until we get to about 0, the graph is going up, or it's increasing. And then from the other side of 0 until we get to a positive infinity for x, the graph is once again increasing. The following data represents the resting metabolic rate in kilocalories per day for the mass in kilograms of several selected animals. Create a scatter plot. So when you go to make the scatter plot, you are going to need to label your axes first. Then you're going to plot each individual data point. After you have the scatter plot created, we need to write a polynomial function. So if we take a look at this one, our graph, if we were to draw a graph, would be arcing this direction. So we could write this as a power function. So if you put this information into your calculator, into list 1 and list 2, and then you try to write a power regression. Remember, you can find that by going to stat, going over to calculate, and selecting power regression. you should be able to write an equation that fits the data in the form of a power regression. Now, if we need to predict what the resting rate would be for a 12 kilogram animal, we would plug 12 into our function, and we would get that the resting rate would be 514.98 kilocalories. We need to solve the equation. To do this, we're trying to get the x by itself. The first thing we would need to do is to subtract 14 from both sides. So this is going to leave us with the cube root of x minus 5 squared is equal to 36. Next, we need to get rid of that cube root. So you will cube both sides. So it's going to leave us with x minus 5 squared is equal to 46,656. To get the x by itself, we are going to take the square root of both sides. But since you are taking an even root, you do need to remember to put that plus or minus in front of it. So we have x minus 5 is equal to plus or minus 216. So we're going to have two separate answers. We're going to have x minus 5 is equal to a negative 216, and an x minus 5 is equal to a positive 216. Now, to solve for x, we are going to add that 5 to both sides on each equation. And you're going to end up with x is equal to negative 211 and x is equal to 221. Now remember, you need to check this for extraneous solution, so you will need to take these x's and plug them back into the original equation to make sure you get the correct answer. But in this case, you will get the correct answer for both values. Describe the end behavior of the graph of each polynomial function using limits, and explain your reasoning using the leading term test. So to use the leading term test, we first need to rearrange this formula so it is in order from largest exponent to smallest exponent. Remember, our leading coefficient is the number that is in front of the variable with the largest exponent. So in this case, it is negative 5. So we know that it is negative. To find the degree of your function, it is the largest exponent that you have, which tells us that this is odd. So our reasoning for what our end behaviors are going to do is because this has a negative leading coefficient and an odd largest exponent, where the degree is odd. So since we know it's odd, we do know that the two ends of the graph are going to go in opposite directions. And since it's negative, we know it's going to go up to the left, and we know it's going to go down to the right. So the end behavior on the left side of our graph is going to go up to positive infinity. The graph on the right side will go down to negative infinity. State the number of possible real zeros, possible number of turning points of the function, and then define all real zeros by factoring. So to find the number of possible zeros, remember that is just your n value, or the largest degree, which in this case is 3. To find the number of possible turning points, that's just n minus 1, which in this case is 3 minus 1, or 2. Now find all of the zeros. We're going to start back at our original equation, and I can factor an x out of everything. So that's going to leave me with x squared minus 5x plus 6. Then I can factor that equation. What multiplies to get x squared is x and x. What multiplies to get a positive 6 and adds to get a negative 5 is negative 3 and negative 2. So we know x is equal to 0, x minus 3 is equal to 0, and x minus 2 is equal to 0. Or x equals 0, x equals 3, and x equals 2. Make sure to check for multiplicity when you are writing your answer. The average personal savings as a percent of disposable income in the United States is given in the table. Create a scatter plot of the data and determine the type of polynomial function that can be used to represent this data. So if you graph this data, first I would change this to year 0, then that would make this year 10, 20, 25, 30, 31, 32, 33, 34, and 35. You can put the years into list 1, your percent savings into list 2. And then your graph will look something in the general form of this. So if we were to draw a curve that goes through your data, it would look like this. So your options are, you can write a power regression, a quadratic regression, or a cubic regression. Since both ends are pointing in the same direction, we know that it's going to have an even degree, so we can use a quadratic regression. Now to write that polynomial function, again, remember you can hit stat, go over to calculate, and then you will select quad reg to write our quadratic regression. And in this case, our equation would be that f of x is equal to negative 0.009x squared plus 0.033x plus 9.744. If we want to estimate what the savings will be in 1993, you're going to see how many years that is from 1970, which in this case would be 23 years. So you can plug in 23 into your equation. And if you solve this, you should get 5.944. So we would expect the percent that they would save in 1993 would be 5.944% of their income. And we need to use the model to determine the approximate year and what percent the savings would reach 6.5%. Now to do this, you would go back to your graph. You would need to have stored your equation or put your equation into y1 for your graph. And then for y2, you would just use the equation of 6.5 because that's the percent that we are trying to figure out what year it is. Your graph will then plot a straight line at 6.5, and you are looking for where the two graphs intersect. And you're going to estimate what the x value is in that case. And where they intersect is around when x is equal to 21. So 21 plus the 1970 would mean that we would expect their percent savings to be around 6.5% in 1991. Divide using long division. So remember, when you're doing long division, this is how we set it up. Now you want to see what you can multiply 2x by to make it look like 8x to the third power. In this case, we would need to multiply by 4x squared. So 4x squared times 2x gives us 8x to the third. 4x squared times negative 3 is going to give us negative 12x squared. You are going to subtract down. So 8x cubed minus 8x cubed, those are going to cancel, nothing's left. Negative 18x squared minus a negative 12x squared, this is going to turn plus positive. So negative 18 plus 12 gives us negative 6x squared. We are going to bring that 21x straight down. Now, what do we need to multiply 2x by to make it look like negative 6x squared? We would need to multiply it by negative 3x. So negative 3x times 2 is negative 6x squared. Negative 3x times 3 is a positive 9x. Again, we are going to subtract down. Negative 6 minus negative 6, those are going to cancel. 12x minus 9x is going to leave us with 21x, minus 9x is going to leave us with 12x. And then we are going to bring that 20 straight down. What do we multiply 12x by to make it look like sorry, what do we multiply 2x by to make it look like 12x? We would multiply by a positive 6, which give us 12x minus 18. Again, we are subtracting down. Those are going to cancel. Negative 20 minus negative 18. This is going to turn plus positive. So negative 20 plus 18 gives us negative 2. We're going to take that part and bring it up here for a remainder. We're going to put it in a fraction and put it over what we were dividing by. To do synthetic division, we first need to set what we're dividing by. Remember, it does have to be in the form of x minus c first. Once it's in that form, we're going to set that equal to 0, and we're going to solve for x. And we're going to get x is equal to 3. So the 3 is going to go out front. If we bring the first term straight down, 3 times 6 gives us 18. We add down. Negative 25 plus 18 gives us a negative 7. 3 times negative 7 gives us a negative 21. Add down, we'll get negative 3. 3 times negative 3 gives us a negative 9. Add down, 9 plus negative 9 gives us 0. Now, since our equation started with 6x to the third, and we just divided by one of the x's, that's going to reduce our degree by 1. So instead of being 6x to the third, it's going to start out being 6x to the second minus 7x minus 3. Determine the FOC using synthetic substitution. Now, when you're doing synthetic substitution, we already know the x value we're plugging in. We just need to first make sure we didn't skip any exponents. And then we're just going to use synthetic, just like we do synthetic division for synthetic substitution. So we're going to bring the 10 straight down first. That's going to give us negative 60. Add down. Multiply negative 6 times that negative 54. Add down. Multiply negative 6 times 3, 16. Add down. Multiply negative 6 times negative 1,889. Add down. Multiply one more time. Add down. So we know that f of negative 6 will equal negative 67,978. Use the factor theorem to determine if a binomial is a given factor, and then we're going to use it to write it in factored form. So again, to do this, you're going to have to set them equal to 0, and we're going to get the x by itself. Now, if we use synthetic division and we end up with no remainder, we know that it is a factor. If we do not end up with 0 as a remainder, then it is not a factor. So let's test the negative 3 first. So if we bring down the 4, we're going to multiply, then add down, multiply, add down, multiply, add down, multiply, add down. So we do know that x equals negative 3 is a 0 of our function, and the x plus 3 will be a factor. Since that one does work, when we go to test 1, we don't have to go back to the original problem. We can just work with what is left. Now, if that first one didn't work, we would have to go back to the original problem to start with it again. So 4 times 1 gives us 4. Add down, multiply, add down, multiply, and add down. Since we did not end up with 0, we know that x equals 1 is not a 0 of our function. So to write this in factored form, we know that we factored out an x plus 3, and after we did that, because this was to a fourth power, we're going to be left with a third power. We would be left with 4x cubed plus 9x squared minus 2x plus 1.